In this video, we're going to learn how to graph a polynomial function. In this case, this graph is a cubic function. So we first want to observe what our end behavior is going to be. So because the degree is odd, is the highest exponent in the polynomial, and the leading coefficient is positive, this is an odd positive graph. And that means that the rightmost point of the graph will go up and the leftmost point of the graph will go down. Because it's odd, the arrows face in a different direction, and because it's positive, the rightmost point goes up. So usually I start to make a function table by plugging in 0 and then using numbers around 0 until it doesn't fit on the graph anymore. So if we plugged in 0, we would get 6. And then we can try to plug in -1, 2 times -1 cubed, -7 times -1 squared plus 6. And -1 cubed is -1 times 2 is -2. -1 squared is 1 times -7 is -7 plus 6, which ends up giving us -3. So that point works out. If -1 works, then we'll want to try -2. And I'm going to plug these in. You can do it on your own. I'm going to do it on my calculator. 2 times -2 cubed minus 7 times -2 squared plus 6, which ends up being too big. We get -38. Okay, so we don't want that point, but we can go in the other direction and do 1 and maybe 2. If you plug in 1, you get 1, so that works out. We'll try 2. And you get -6, so we're still getting good points. We'll try 3. And that gives us 32, which is too big. So we have 4 good points. We'll plot those on our graph. We have 0, 6, 1, 1, 2, -6, and I also had -1, -3. So when you look at this graph, it doesn't look anything of relevance. It looks like points all over the place. But what we do know is that your rightmost point will go up and the leftmost point will go down from your end behavior. So we can put that on our graph. Rightmost point goes up until infinity. And you kind of want to take up the whole graph to get a good idea of what it looks like. And the leftmost point will go down until infinity. And then you'll connect the points in the middle. So a little bit funky of a graph, but as good as it's going to get. Maybe you want to edit this a little bit and make it just go up. And that is a very drastic cubic graph. So the domain here, we always talk about domain and range. The domain is all real numbers because the graph gets wider and wider and wider as time goes on. So -infinity to infinity. The range also, one arrow goes up until infinity forever and one arrow goes down until infinity for forever. So the range is actually the same thing. All odd graphs will have a domain and range of all real numbers for both of them. The relative minimums are found at the lowest points on the graph, or the valleys. You think about mountains and valleys. So approximately right here, which was -6, was a minimum. And then a maximum would be right here at +6. We can also talk about the end behavior. So as x, we can write it out as x approaches infinity. We want to know what f of x does. And f of x, as x approaches infinity, goes up to +infinity. As x approaches -infinity, f of x approaches, and as we go to the left, f of x goes down, so -infinity. These would be the two answers that you would give. increasing and decreasing intervals. The place where this graph increases is this interval and this interval. So that starts at negative infinity. It's always increasing until we get to 0. And a lot of kids try to put 6, but that is the y value. We're looking at intervals, which are x values. So the increasing is going to be from negative infinity to 0. And then it starts up again right here at 2, and then to infinity. And the decreasing interval should always be between these 2 points, so from 0 to 2, which, as you can see, is the decreasing interval from 0 to 2.